Hi guys, so welcome to this class on general organic chemistry again. So today we will be discussing more about the important aspects of general organic chemistry. So let's have a quick revision of what exactly we will be doing. We'll be doing something about the bond displacement effects. Yes, exactly. We are talking about inductive effect. So we'll be talking a little bit about resonance effect, right? And maybe something like hyperconjugation in this particular series. Okay, so let's talk about bond displacement effect. Now let's say if you have a bond between A and B, right? So A and B are two different atoms. Okay, so now what exactly could happen? So just imagine A is going to contribute one electron, B is going to contribute one electron, as a result of which this bond is formed. Okay, let's try to understand that this is just a covalent bond. Now what would happen if B tries to pull the electron of A itself? So what happens is, here is A and here is B, right? B has its own electron. Okay, now it has already pulled the electrons from A. So what exactly happens over here is the bond has slightly shifted towards B, right? So A is now going to become electron deficient, so it gets partial positive charge. Okay, B is acquiring the electrons of A, so it should get partial negative charge, right? So this is what you call it as bond displacement effect. So what do you mean by bond displacement effect? Bond displacement effect is an effect in which the electron is displaced towards one atom. Okay, so now what exactly is going to happen, that we'll be studying when we'll be doing inductive effect and all. Now here is a very simple explanation which I've given. There is carbon which is connected to a group. Okay, this group could be anything. So the first category is this one. When electronegativity of carbon is approximately equal to electronegativity of the group, that means we are talking about the CH bond, which is covalent. So what exactly will be having? Carbon is going to pull the electron pair towards itself. Carbon is going to hold its electron pair. That's the best way to understand. And the group itself is going to hold the electron pair. So as a result of which the bond would be stable. I won't say stable, but bond would not be moving, right? So it's going to be like equal contribution of electrons, right? Now let's talk about this particular category. Okay, so what would happen if the electronegativity of this group, let's say if this is X is nothing but a halogen. So halogens are highly electronegative, so they are going to pull the electron pair, pull the electron from carbon, right? As a result of which this situation is going to arise, right? So this could be the case. Now in this case, electronegativity of group is less than carbon. So what exactly does this mean? This could be something like a sodium metal, right? Sodium metal. Metal, it could be any metal, right? So metals are generally electropositive, if you remember. So as a result of which, let's say if this is a metal, and metals are generally electropositive, so I would put a partial positive charge here. Here it's going to be partial negative, right? So what has happened in every cases? So if you could say this is positive pole, this is negative pole, right? So what has happened is basically the polarization. Okay, what has happened is polarization of a single covalent bond. And why did this happen? This happened in the following cases. First, electronegativity of group was greater than carbon. Electronegativity of the group was less than carbon. That means you could say that there is considerable electronegative difference. Okay, yes, this particular effect is called as inductive effect, right? I effect. Okay, so this is about a very short discussion about the inductive effect. So anyway, we will be solving a lot of questions. So it's always better to have some clear-cut idea on what exactly we are going to study in the upcoming slides. Okay, so this is bond displacement effect, and we had a little bit overview of the inductive effect. Now let's see this. So now electron displacement effect, whether you talk about electron displacement or bond displacement, it's one and the same. They are of two types. First is a permanent effect. Now this permanent effect is normally going to take place in the case of single bonded systems. Now temporary effect, this could happen in double bonded and triple bonded systems. Okay, permanent effect is inductive effect, hyperconjugation, resonance, and application of resonance, that is mesomeric effect. Inductometric effect, that's not the part of your syllabus anyway. So electromeric effect, That is, this is normally operates in the case of multiple bonds. So let's have a discussion of inductive effect. So let's say if you have a carbon chain like this, okay. So chain containing 4 carbon atom. Now this is attached to a group, right? Let's say if this is an electronegative group. So what would this group do? It will be pulling the electron pair from carbon, right? As a result of which this acquires a partial negative charge. This will be acquiring partial positive charge. Now this carbon has become electron deficient, so it will be pulling from the next carbon, next neighbor, right? So there will be slight positive charge here. So we would write partial positive. Now this would pull from the nearby carbon, so this is going to be delta 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 positive. This is going to be again delta 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 positive, right? So if you could see the pull is going to diminish as you move from this end to this end. This is what is the application of inductive effect, right? So it basically depends on distance. Okay, so inductive effect, you can say I effect decreases when the distance increases. Okay, so now if you could see here, carbon is getting a positive charge, right? So that means carbon is pushing the electron away from itself, right? So carbon is acting like an electron donating group, right? So this is called as a plus sign, right? Now what would happen if carbon withdraws electron? So you would be having electron withdrawing group, right? And so this could be something like a minus I group. Okay, so plus I means electron donating effect and minus I means electron withdrawing effect. So now let's see the next part, what we are going to discuss. Okay, now you have plus I effect. Now what would happen? This Z, okay, this Z, yes. So if you could see here, when Z is less electronegative than carbon, right? So what would happen? Carbon will be pulling the electron, so carbon gets partial negative charge, right? So this particular Z, this Z is said to exhibit electron releasing effect. This is called as plus I effect. So when would this be possible? When Z is electron rich. So if you could see, all alkyl groups or all metals which are generally electropositive, they are basically plus I groups. Okay, now let's talk about minus I. So if you have this atom X, which is highly electronegative, right? So what would this X do? So this X is going to pull the electron pair, as a result of which this would get partial negative charge and carbon gets partial positive charge, right? So X is said to exhibit minus I effect. Now, what exactly could be the criteria for X? X should be electron deficient, right? Electron deficient, or it could be something like more ions attached, more electronegative atoms should be present in the group. So if you could see here, when I am talking about NO2, this contains 1 nitrogen and 2 oxygen. So let's say if I have a substrate X, to this if I am attaching NO2, right? So I'm going to write N double bond O, and there is going to be an O here. This is positive, this is negative. So if you could see, N is surrounded by 2 electronegative atoms. So 2 electronegative atoms are going to pull electron from N, as a result of which N will be pulling from X, right? So in general, X will be experiencing a pull of electrons, so it will be pushing the electron towards N. So this N is going to act like a minus I group. Okay, so there are many more. You have OH, you have OR. Now OH, if you could see, there are lone pairs as well. So you can lone pair could be easily donated, but it's very much important to understand that what type of atom is attached to the ring. Okay, like for example, if you have OH, OH is attached to something like a cyclic system, right? So in this case, O is going to pull the electron from carbon because carbon has sp3 hybridization here, right? But the moment when OH is attached to something like a double bonded carbon, okay, so this is the OH. Now you have, this is sp2 carbon, right? So this is more EN, more electronegative. So as a result of which oxygen will be donating the lone pair. So the cases are different, that's what you could say. Now, applications of plus I minus I effect. Okay, so I would say applications of plus I minus I effect, it could be best studied when you do certain examples. So let's see a few examples. Okay,